Hi, everybody, and welcome back. So today, again, hopefully should just be a really quick video because I hope you guys all saw my announcement on Google Classroom a couple days ago that you're going to have another check coming up in a few days. So today we're just going to spend reviewing everything that we've been talking about with quadratic functions. It's pretty much the first half of Chapter 8, if you guys need that information, if you still look in the textbook for anything. And so honestly, a lot of these questions that you're going to see are very similar to the stuff that you saw, I believe it was the last homework assignment. So the first question, I believe, was just figuring out everything from a visual perspective, right? Your parabola is right here, and here's your vertex all the way up at the top. That point is your vertex. So what actually is it? Well, it's -2, 4. In this case, because it's the highest point, it is a maximum. Excuse me. If it was the lowest point, then it would be a minimum. Direction, we can obviously tell that it's opening down. The AOS, or the axis of symmetry, we should be pretty comfortable by now realizing that that is the x value of the vertex. It is also the line that splits the parabola perfectly in half. And because it is a line, we do want to write it as in slope-intercept form like we did many months ago. So because it's a vertical line, I said this a million times at this point, it's going to be x equals whatever that number is. So in this case, it's x equals -2. Domain is always going to be all real numbers. The range, range deals with the y values, all right? So we know that. Since it's opening down, all of the other y values are going to be less than the y value of that vertex, that point up there. So it's going to be less than or equal to, because that's a closed circle. And it's less than or equal to whatever the y value of your vertex is. Because again, your vertex is your highest point. So since we're dealing with the y's, the y value of your vertex has to be the highest. So it's going to be y is less than or equal to 4. For the zeros, I'm going to try to fit everything in. Zeros, again, are just your x-intercepts. So the places where the line or the curve crosses the x-axis. So that's this point right here and that point right there. Again, since it's an ordered pair, I am going to be looking specifically for ordered pairs. So that means not just -4 and 0, but -4, 0, and 0, 0. And then the y-intercept is where the line crosses the y-axis, which happens to be the exact same place here. So your only y-intercept is 0, 0. And that's it. So when we find, well, let's go in order, all right? Vertex and axis of symmetry. You actually need the axis of symmetry before you can find the vertex, because again, the axis of symmetry is the x value of your vertex. So axis of symmetry is going to be the same -b over 2a. And if you can't really read this, it's using the b and the a value from your original problem. So b is -14, -14 is +14 over 2 times our a value is 7. So this is 14 over 14, which is 1. So the axis of symmetry is x equals 1. Now for the vertex, again, axis of symmetry is the x value of your vertex, so we're just going to take that point, or that value, and plug it into the equation everywhere we see an x. So this is 7 times 1 squared minus 14 times 1 minus 245. So 1 squared is 1 times 7 is 7, minus 14 minus 245. So this is probably going to be a pretty big number. Let's see. Yeah. So this is -252. So I would never ask you to plot something like this, but you can at least figure out that your vertex is 1, -252. All right. For the zeros, it's been a while since we've done stuff like this, but zeros, again, for the longer explanation, Zeros are your x-intercepts, and the x-intercepts are wherever it crosses the x-axis, and the y value is always 0, and f of x is just a fancy way to say y. So when you plug in 0 for this whole thing, you set the whole thing equal to 0, and then you can solve this either by factoring, completing the square, quadratic formula, whichever way makes the most sense to you. I'm pretty sure this is factorable. I'm pretty sure everything that you've gotten up to this point is factorable. So I'm just going to stick with factoring. Sorry about that. So for factoring, we're going to want to look for a GCF first. So are 714 and 245 all divisible by the same thing? I believe so. 7 and 14 are definitely divisible by 7. And 245 is also. Cool. So this is going to be divisible by 7. Now we have 1, -2, and -35. So 7 goes on the outside. And this is 1x squared minus 2x minus 35 equals 0. So now we're just going to work with what's inside the parentheses. We're looking for factors of -35 that add up to -2. I mean, 5 and 7, I think, are factors of 35 that add up to, yeah, 5. Well, so we've got, okay, we'll do the whole thing. -1 and 35, 1 and -35. And I think other than 5 and 7, that's it. So 5 and 7 is definitely going to be it because of the signs that we've got going on here. And since we're looking for -2, it would be 5 minus 7 is -2. So that's the pair we want. X plus 5, x minus 7, 7 is a GCF, equals 0. And now we can break this up and solve. Again, 7 equaling 0 is not possible. It makes absolutely no sense. So we're just going to stick with x plus 5 equals 0 and x minus 7 equals 0. And then solve. So x is -5 and x is 7. But again, these are x-intercepts, so they're ordered pairs. So -5, 0 and 7, 0 is a slightly more accurate answer because of what the question is actually asking. Okay? All right, last one is the kind of thing that you guys have been used to. All right, where we're just going to go through a lot of this all over again. Domain, we know, is going to be all real numbers. The y-intercept comes from the c value of your parabola, so this is a -6. So 0, -6. Axis of symmetry, we can do exactly the same way we did before. -b over 2a. Our b value is 4, so -4 over 2. And our a value is -1. There is a negative in front. So 2 times -1. This is -4 over -2, which is 2. Oh, you can't even see that. So the axis of symmetry is x equals 2. We're going to plug that in for our vertex. So negative parentheses 2 squared plus 4 times 2 minus 6. So this is 2 squared is 4, -4 plus 8 minus 6. -4 plus 8 is 4, minus 6 is -2. So the vertex is 2, -2. In regards to our table, we're going to put the vertex in the middle. And we're just going to count up and down. So, got it. So we have 2, 1, 0, and 2, 3, 4. 0, again, we already have because that's our y-intercept. So this is going to be -6. It's symmetric, so 4 all the way down at the bottom should also be -6. Again, you can double check all this by plugging it into your calculator. 1 or 3, we're going to have to do a little bit of work for. If you are plugging this into your calculator, please be careful with your parentheses. -1 squared plus 4 times 1 minus 6. So you're squaring the 1 first and then making it negative. This is -1 plus 4 minus 6. -1 plus 4 is 3, minus 6 is -3. So both the 1 and the 3 are going to have a y value of -3. All right? And then we can go in and graph all this. Try to make this curve as nice as you can. Extend the line. Don't forget the arrowheads. And then before I forget, the range, same kind of thing as last time, or the first problem. Y is less than or equal to, because it's going down, whatever the y value of your vertex is. So it's less than or equal to -2. Okay? And there you go. That's your entire review. That's pretty much everything that you're going to need for your next check. I think your review sheet is going to end up looking pretty similar to, if not the last homework assignment, some recent homework assignment on all of this, but I assure you the questions are different. And yeah, you know where to find me if you have any questions. And that's it. Talk to you guys soon.